right, here we are live. Hello, everybody. Anybody who is watching either live or watching the pre-record or the not pre-recorded, the recorded stream later on. This is a Random Code stream. My name is Jason Bach, and it is Thursday, 8:15 on March 31st. Yes, because tomorrow is a day that I despise. In fact, I should have taken the day off. I really don't like April Fool's Day. I really don't like it at all. It's kind of one of these holidays where people can just make up anything they want and justify it in the name of, oh, it's a joke. It's April Fool's. Yeah, I personally don't really care for that. But anyway, it is not April Fool's tonight. So nothing I'm going to be talking about is a joke unless I inadvertently say something that's funny. This week has actually been Microsoft's MVP Summit, which unfortunately was virtual. It just doesn't cut it. It doesn't cut it. I mean, it's no fault of Microsoft. It's no fault of them. It's just virtual conferences. They don't work. They just really don't work. And I do want to be sensitive to somebody making a comment once in a user group that I was doing last year, which was virtual, and saying having the event online was actually good for him because he had a hard time driving at night, which is when the user group usually met. And he was happy that he could actually attend these because he couldn't do it before, or it was difficult for him to do it. So from that perspective of, hey, I can be part of a conference, even though if I can't physically make it or it's not easy for me to attend, that I totally get and I totally understand. But and it's not a but. It's just the ability to just interact with other people, talk with other people, converse with other people is just so much easier to do in person than it is virtually. So while there were some things that were cool to watch, some of the demos that they did, I think none of anything I really saw was NDA. The .NET stuff is pretty much all in the open, and this I know is not NDA. It was showing some experiments that they're doing, which you can actually, if you look up Steve Sanderson's account on Twitter, he posted some of the work that they're now doing with WASI. And that was kind of interesting. That was kind of cool to see them actually build ASP.NET Core and host that in the browser. that was just like, what in the world? That pretty cool. I mean, there's the practical aspect of it too. It's like, well, what would you really use this for? And like it says, you really would not want to do this. This is not the right application for it. But it's kind of a cool just experiment to show. So that was this week. I've also been struggling with some build stuff on the job and learning YAML. I've never had to touch YAML until very recently, and it's hard to try to fix something when you don't have any expertise in the technology that you're trying to debug. So it's been a learning experience, and I've discovered that I definitely need to amp up my YAML skills for good, bad, or worse, or whatever it is. I need to understand it. I need to understand how this all works and ties together, and so that I can figure out when there's problems like what we've been running into. It's just the nature of the beast. It's funny though that one of the first projects I was on, that was a .NET project, was back in 2003, and we were using cruise control on a build server. And while the tooling is better, and say what you want about YAML, but the basic core concepts are still there. You build, you run tests, you ship your product to, in our case, would be a NuGet server, that type of thing. NuGet wasn't a thing back then, but we could put our application out somewhere that people could test against it. And so, there's those things still, are tried and true concepts that have been around for many, many years. So stuff's still the same, even though arguably things are much better in a lot of ways these days. But anyway, drinking some, I actually have my, I don't know if you can see this, but I've got my, which way do I want to go? This is it's called Von Rottenberg's or Von Rottenberg's. I don't know how you say it, but it's or was, I think it still is. I think it still exists in Germantown, Wisconsin, which is about half an hour-ish northwest of downtown Milwaukee. It's a small German styled bar, although they just serve beer. That's it. And I used to go there when I lived in Germantown for a couple of years. I go there every Thursday night and have a couple of different beers that I've never had before. And it was a educational experience in terms of just trying different stuff out and going, oh, this is good or this is bad. And, you figure out what you like or what you don't like. So still have this shirt because if you filled up the card to 50 beers, you got one shirt, I think a red shirt. If you ended up trying 100 different beers, you got this one. This is the green shirt. I never did the 150. And no, that wasn't in one night. That was spread over many weeks. So anyway, what am I going to get to tonight? Let's go to the code. So I think in the last stream I was looking at some ways to improve the performance in rocks, especially around the actual code generation part of the generator. And when I did some profiling, I noticed that, there's a couple of places to look at. One is the transform targets, especially with using the symbol information. The problem is that if you look at the way the generator, the generator works, is arguably maybe in transform targets, I shouldn't be doing any symbol stuff. I should just be returning the actual invocation, the expression syntax node. And down here in the create output, that's where I would start to analyze the actual invocation syntax node and figure out, is it one of our methods that we're looking for? But we're still going to have to, at some point, get the symbol information from that, or the semantic model for that context or that node in the compilation. We're going to have to do that. We can't, well, I guess we could, but doing all the work, just using the syntax tree, I think would be a lesson in frustration, or an experience in frustration, to say the least. It would be much, much harder to figure out certain parts. At least I think so. So I don't really want to do that. I'm not really sure if that actually gains us that much anyway. So, but it might make more sense to move that stuff out of the methods in the pipeline until we get to the last part, which is create the output. Because probably in that case, the method we're looking for is the method we want. And then we can do this work, even though this is really, really a small piece of it. We can do this once. And then for all of the target nodes that we're getting, we could do that comparison out, just get these values and do that once for all of them. But that's not the first thing I want to look at. The first thing I want to try is some things with the actual indented text writer, because most of the build part, most of the part that's actually creating all of the code uses an indented text writer. And so I thought, in fact, if I go back to the graph here, I think we want to go to flame graph. Let's go to call tree and do expand hop path. I think if you start diving into these, well, there's string format helper, but then there's write line. I think in most of these, you're going to find that the first thing that we do, or the first thing that's taking out the most time is, well, there's two display string. That's one, but yeah, I get distracted so easily with this, so easily. But I did notice that most of the stuff seems to be around, see if we just do functions. That's probably another thing to look at. Can you actually search on function name here? If I said like write line. Really? System, that's it? I thought it'd be more than that. 283 calls. And it's only taking up 1.63 of the total time. That's actually quite surprising. Transform targets is definitely taking up a fair amount of time, but again, we have to call get symbol info. I don't know how we're going to get around that. The create out. Anyway, I got the feeling that this is not quite showing exactly what I'm looking for. But I could be wrong. It could be wrong. Something to try anyway. Which is, can we make it a little bit faster and take up maybe less memory? And so one of the things I was looking at doing is saying, okay, let's do some experiments. And so I said, let's just create some text using an indented text writer. So I said this whole thing here, because this is 100 bytes, you do that 10 times, it's 1,000 bytes. I looked at one of the files that's created, and I noticed that for a simple one, it takes about 4K of characters to create. So I said, well, let's do an approximation. This isn't the same thing, but easier to control. And so we create a bunch of text using a string writer and an indented text writer. Okay. And let me just check something here while I'm curious. Yeah, it's a text writer. Now, there isn't anything in string writer here to say, I want to start with a capacity. If you notice, there's a way to pass in a string builder. So I thought, okay, well, let's do the same exact code, except let's pass in a string builder to the string writer and set its capacity to a value. And so I basically did a whole bunch of values to say, how does it behave as we're getting closer or moving away from the target? Okay. Which again is around, in this case, around 3K. Okay. And so I ran this, and I think if I have this here, yeah. So this is the one, yeah, this is the one I'm looking for. So if you do it the way I'm doing it now, it takes about 1.7 whatever microseconds and allocates about 13K of memory. Okay. If I change the capacity, even if I only do like an order of magnitude under what it is, it does start to get a little better. Okay. And as I get closer to what it should be, you notice if we get really, like if we get on the money, really close to what the size of the generated text is, our speed gets much better. In fact, if I do like calc here and I say 1.739, no, 1.739 minus, was it 1.317? Say divide by 1.739. But 25% faster, something like that. So not insignificant. Okay. The memory seems the same, although we get into Gen 1 collection. That was kind of odd to me, but whatever. Okay. So even if we went well over what we thought it would be, it's still faster. We do tend to the jump in the amount of memory consumed, which I thought was interesting. So even if we go over, you would think if I set the capacity to 12K, it seems like if I set it here to, I'm just looking at numbers, 3K, it's 4 times 6 times 4 is, it's not a times 4. That'd be 4. No, it's not that, but it does start to go up, because it makes sense in a way, because at some point it's going to have to allocate more memory to do all the stuff with strings. But if you start actually going up in here, you're hitting areas where you're not using what you said the capacity is going to be for the string builder. So that makes sense that, your performance is slowly going to start to rise again because you have to allocate a little bit more memory. And you're just allocating more than you should. But this made me think this might be a really easy bang for the buck, because all I have to do is when I create the string writer is I just create a string builder. and then return its toString, and that's it. So this doesn't require me to change a whole bunch of code in the generator itself. It just means I need to change essentially two places and see if we get a benefit. Now, let's first do some things because as I mentioned before, why do you do that? Uh, no, what? Why are you on a Server Explorer? I don't want that. Oh, I know why. That's why. No, I don't. You here, window. Close. No, I'm on Rock Creek Builder. Why do you think I would want to say, oh, for Pete's sakes, close control? I'm just going to get used to that. Control 4. So we'll do that and we'll say close. Close that. That's fine. Let's keep these up. That one. As I noticed last time again, when I'm doing this stream, doing perf numbers, stop it. Doing perf numbers gets skewed because I'm streaming right now. Go back to here. There was pointers generation and simple generation. One of the things I'm also going to do is come up with a best guess as to say, how many methods, mockable methods did you find, or properties, or events, or constructors? And then based on that, just come up with an estimate to say how much text do I think I'm going to be creating. And I want to make that really, really fast and really simple. Nothing that starts to actually get too far down the road of, how much do you think you'd actually create? Because that in turn may start to actually allocate some strings or whatever. And we don't want to do that. We want to just say, hey, if you've got one method or n number of methods, you're probably going to generate X amount of text in the generated code. If you're going to have properties, it's going to generate this much and so on. So what I want to do again is just run these tests. Even though it's probably going to cause my, wait, what did I just do? Cancel. Build configuration manager. Yes, we are in release. I think this is actually going to make my video pretty choppy, but that's okay. But because I want numbers that are going to be somewhat relative and seeing did we actually make any improvements or not. So if smoke them if you got them. That's actually something I was talking to my kids about, which is I remember when I was going to high school, not that a lot of kids smoke, but you definitely had kids that were smoking. And now you barely see, at least I don't see a lot of young kids smoking anymore, at least where I am. And which is a good thing. Don't get me wrong. That's a good thing. But it's definitely not as prevalent as it was when I was a kid. So that's kind of good. So a phrase like smoke them if you got them is probably going to start to lose its understanding. All right. So that's what we're going to work with the simple generator for tonight. Okay. And then back here, let's do, I think it was called pointer, because if you do a pointer, that's going to do even a lot more. Does a lot more generation because it actually has to generate types for certain things on the fly. This is a rare case though. Things that need this custom generation of delegate types and other types, vast majority of the time you don't run into. And I don't want to peruse any of the members to see if they have pointers because it's such a rare case. And again, we're just trying to do a simple best guess of size. So let's see here. So we'll do this and then we'll look at some of the generated code and how much text it's taking to kind of come up with a best guess to say, how much do we think this is going to take? So the pointer one, yep, that's a little bit more. Not too surprising. Okay. This is simple. And this is pointer. Okay, so let's actually play with this. So if I come into We'll do that for it. Go back up into rocks. No, I want to go to integration tests. So let's say interface method void test. Okay. So yeah, we want to now look at dependencies. No, not that one. That. Let's say interface, I interface void. Okay. So how much do we think we're going to be creating? Okay. Well, if we have any methods, so let's yeah, conferences I want to apply to and speak at. If we have any methods, well, let's make some notes here. Methods. Any create this much because it's 130. You know, yeah. This is rough because it's including the name of the actual type, um, which it might be smaller than this. So I'm going to say this is just pure ballpark guessing, but we know we're going to have at least that generated. Okay. We also know that we're going to have, just say for constructors, we have at least one. So we could say whatever that is, this. Okay. That is, oh, I forgot some stuff here. That is what? Selection is 300. So we can say 300 times n, the number of constructors. Okay. So if we have, we'll get back to that one. Okay. The actual interface, for the actual mock is going to be this, right? I could have done this all before, but this is why I'm doing it live, because I wanted to do this estimation live. We're going to have at least this amount. It's about 300. Okay. And for each method, now we're going to have that much. That's what? 475. We'll call it 450. So we're going to say plus 450 times n. Okay. We got that, that. And then the method expectations interface methods. Okay, so let's just pick one of these. It doesn't matter. Again, just a guess, just a guess. Let's say for each method, it's like 223. We'll say 200. Okay, so plus 200 times n. So that should give us, if you have a method, the mock itself, we actually want to include, I think, that amount. That's like another 86. We could say 50. 50, because why not? And then we're going to actually also have some extraneous junk up at the top here, which is this stuff. That should be enough to give like a little bit of a buffer. That's 87. We'll say plus 250. We want to be under, not over. So being a little bit more conservative is better. Okay. Now this is if you have we had a method here. Okay. Or methods. So we figured out that we really should have about 100, 450. A constructor is going to be approximately 300, though I do want to see what happens, because this constructor value here, actually the way I'm doing this is If we have methods, it's going to be that value. Yes. If we have constructors, and we're going to have constructors because you have to have at least one. You have to have that instance call there. So there's going to be always at least one. The mock is the superfluous stuff that's up and around everywhere. What happens if we have a constructor? Class constructor. So what am I looking for here? This is, I think, the constructor is we're looking at the instance here and we do those. I don't think that really affects anything else. Wait a minute. I want to interface method void. Yeah. $100, 130. So we could say plus 100. And then so every constructor that comes in gives you at least that. You're always going to have that. You're going to have the base. It might be a little bit more, but that's okay. All right. What happens if you have properties? And there's indexers, properties. You're going to have at least properties and at least the getters and or the setters, but we're just going to assume one. The properties is going to give you, you're going to do this, which is about, another properties. That was about 100 plus, say 100 times n for every property that you have. Okay. And then each property will have about this much as well. That is what, 500? So we could say plus 50 times n, all the properties. And you're also going to be generating down here for each one, whatever that is. Yeah. That's about 240. We'll say 200. All right. I think that's decent enough. Both events. What was that doing? Events really don't add that much. So events, if you have them, a little bit of overhead, and that you're going to have about. Which Visual Studio had what I select, how much is that? That's like 50 plus, and then there was something up here. Now, $30 times the number of methods. What happens if you have properties that have an event? I don't think I ever cared about that. I think the method, we never, that's an interesting point. I don't think I ever put in here that you could raise an event in a property. like a getter or setter. Right, this is, which file is this? That's this one. Right? Yeah, and if you don't have methods, it doesn't put that in there. It's only if you do have methods that we junk in there. Junk. That's the method return with events, method void, property tests. Yeah, we don't. We do. Interface property. We do. Okay, so we'd also say here this basically the same amount of overhead plus 30 times property. And then for each method we get, it's just a tiny bit of code here. That's about what? 35. You just say plus 30 times event count times number. Okay, so this is just a quick ballpark of saying if you have like number of methods, if you have any methods, it's going to be this. If you have any properties, it's going to be this. If you have any events, it's going to be this. Constructors, we always know we're going to get a value. And a mock overhead is going to be what we say is about 600 bytes characters. Okay, so now what I want to do, let's close that. Let's come into here. Let's close all the windows. And let's get back to ROX itself. And I'm still in the right branch, just adding performance tests. So we want to go into ROX. We want to go into the create generator. We want to go into the builder. Okay. And then sorry, I had to move a cord that was in the way. What we want to do is in the ROC create builder. Excuse me. Where is that? That should be right here. So we want to get a builder capacity estimate for, and I think by this point we say, Bill, we should have got the mock information. So we should have all of this here. Okay. So we want to have like a private int get estimated builder size. Okay. Our builder size is equal to 0, and we're going to eventually return that. Okay. Now, first thing we're going to do, well, we can say 600. Okay. Let's put some comments in here because people are going to go like, what in the world? This method gives a rough estimate of the size of the generated code. This is based on looking at generated code and coming up with reasonable estimates of sizes for methods, properties, etc. 600 is the general amount. It will always be created for any mock. This This is, what do I want to call this? These are the usings. Among other things. I can't remember what they all were. Okay. Now we say if this dot information dot knockable. Okay. Greater than 0. Builder size plus equals 100 plus 450 times that plus 200 times that. If this information, the properties is greater than 0, builder size is equal to plus equal to. Just grab that, right? Then you say, and is this. You know what? Method count. I think there's an option to say replace all instances with that, and I just missed it, which is okay. Okay, and then events. That's different. This is this information. It's length plus this dot information is length plus this dot information. Or we already have that. Event. Okay. Already did the overhead, now constructors. Builder size. Algebra. 300n plus 100n is equal to 400n times this set information constructors dot. Never say that algebra is something you won't use in the rest of your life, because I just did. At least I think I did. Okay, so now we have a estimated builder size, and so now what we can say, we can say var builder is equal to new string builder. This dot get estimated builder size. And then instead of indented, I think writer is where we're using writer toString. We'll use builder toString. That's it. That's all. And of course, if we do this, we're also going to want to do this analysis for the make as well, so that it also has the same goodness. Okay. But this is all we should have probably needed to do. So because we have to shut down and start up again to make sure the integration tests work. Let's just run these tests first. Okay. Because hopefully these shouldn't fail. These should also be just fine. We hope. Please. It'll be nice to actually go to a live conference again next week, Thursday and Friday Code Stock. If you're going to be there, I hope to see you there. Looks like we're getting some greens, so that's good. So at least that didn't break anything. And we probably hit that one test that's taking a fairly long time to run. So we're not going to see huge gains with this. I don't expect this to make our generation that much faster. There's a video I saw from somebody today. I think his name is Nick. He was talking about like the speed of compilation if you're using source generators. He was using the new regex expression stuff that's coming in .NET 7. Oh crap! I got 10 failed. Hold on. Why would... Whoa. What the heck? Wait a minute. Oh. Wait. I see what I did wrong, but I'm surprised anything passed. How did anything pass? Oh, these are all the generators and they don't actually test the generation itself. Yeah, I'm an idiot. I bet all these are failing because they're all like, and all those happen outside of yeah, I'm a moron. You have to pass the builder into the writer, you dummy. Come on, help me out here. I'm doing these streams because I want everybody to live debug my mistakes. It's funny though, when you do pair programming, people will notice you've made a mistake before you've even seen it because they have a different context of what they're looking at than what you do. So, but again, have a drink. I should put up on a board here, like things to take a drink when I say it. Right tests, those made it. I may have not been able to find that bug for a while, but it made sense right away because I'm like, yes, I forgot to pass the builder in. So I think I was talking about code stock and looking forward to being in front of live people again. So now all these should pass. And if they do, then we'll have to shut down and start up again. There we go. Okay. Excuse me. Give me a second while 2022 crawls to the open solution. Given that the regular test passed, the integration test should just pass, and then we can actually run the performance test and see, does this make any difference at all? And I even see a difference. So this is why you do performance tests, because you want to see, do you have the numbers to back up what you just did? Okay. So yeah, anyway, the video that I was talking about from Nick was showing if you use the regex, the new stuff that's in .NET 7, because it's using source generators, does this make your build time increase? And if you use a couple, like you're showing, you're not going to notice anything. Like it's going to be barely a blip on your radar in terms of what you're seeing. Now, of course, that's the way that this regex source generator was built, which I am going to be taking a look at. I didn't have time to do that before this one, but I really need to check out their source code and see how they're structuring their source generator to see if I can pick up any tips on what they're doing. Now, he also put in a regex that's like the email regex from like the RFC or something like that. That's ungodly huge regex. That's supposed to be like the official way to make sure that an email is actually really valid, because there's a lot of corner cases with it. And if you use that, then your build time actually jumps up from like it was taking him a second to build all of his code in this simple little app to 4 seconds or something like that. It made it jump significantly, just to get that one to work. So it was interesting. Most of what I'm doing though is pretty controlled. Like the bigger the type that you're giving me to mock with more stuff, it's obviously going to take more time to generate. There's just no way around that. That's just what has to happen. So, all right, let's run all the tests. And then we'll run those two performance tests and we'll see is there any difference between the two. Okay. While I am waiting, no, that can go away. That's one of my notes. What did I just say I was going to talk about? Well, what I need to do is package. I got to get that up. All the test paths. That's good. And then look at this. That's one thought. I'll explain what I'm writing down here in just a moment. God, my writing is looking like absolute crap when I'm trying to rush it. It's just awful. Okay. So we know all this works now. Here's the kicker. Here. And let's do simple generation first. Okay. What happens, if anything? Are we going to notice any change at all with this? Is it going to be a little bit faster? Is it going to be less memory? We don't know. It's going to be a total waste of time. And again, that's one reason I want to, that's something I want to say here is look at regex source generator code. I want to look at that. I want to see what's actually doing underneath the scenes, how it's structuring stuff. So I don't want to forget that. All right. It's funny. I don't think that helped at all. In fact, I think it made it worse. It made it a little bit faster. We're actually allocating a tiny bit more memory. Now, this doesn't mean I'm going to delete this because again, I'm doing this while I'm streaming, and this is really not the right way to be coming up with good performance. So I'm not going to just look at this and go, oh my God, this is horrible. I am kind of curious. One thing I do want to look at, we can do this under the debugger, is to say, what is this estimated build size here giving? Because for a simple interface, it should be only like 2K. We want to be under. The fact though, that this gave us a slightly bigger increase in memory, but it's like, we could have been 49,400 and we're at 50,000. It's like 600 bytes extra memory with a little bit extra, with a little bit improvement in performance. You know what I mean? So like if I do calc here, I just say what's 1.507 minus 1.462 divided by 1.507. Like what? 3% better? It's just not that big of a deal. And even when I run this, when I'm not streaming, this is actually even faster. So did it really matter? I don't know. Let's do the yeah, do that one. And then I'm writing down another note while I'm doing this. Symbols I think the interesting thing too with the regex source generator is that all it's looking for is an attribute that has the regex in it. And so all you need is to find the attribute, pull that string out, and you can go from there. So not to say that what they're doing is trivial. It's not. Generating all that code is not trivial, but I think it's a little bit simpler path of what they have to go down. Wow, that really jumped the memory. Holy crap. Now that is surprising. Oh no, it did. It went down. Performance is about the same. So what I'm finding out is this really worth it? It feels like it's not. Like adding in this extra bit of code to do this where these numbers are kind of just magic numbers isn't really gaining us anything. Okay, so I'm not going to delete this yet. I'm going to do this off camera. Once I get done with the stream, I'm actually going to run these where I'll just comment this out, take the builder out, make this back to being writer, run those tests, and then do it with and see if it made any difference. If it doesn't, then I'm just going to get rid of it because it's not helping anything in terms of that being that big of a change. So, all right, well, you live and learn and you try some things. The other thing that I want to do is, again, see if I can move out of the generator itself, structure how it's doing stuff here, but I want to wait until I read the actual regex code and see. The thing is, there's no good and hard fast rule to say like, we really just need good documentation on generators. This is something that I've been kind of complaining about for a while, and it's extremely powerful. But in terms of documentation, I don't just mean here you implement incremental generator, and then you have this method and you do these things. Like explain, why am I doing these things? Why do I pass these things in? What should I be doing in these things? What should I not be doing in these things? What is what is an incremental value provider? Why am I combining them with things? What comes out of it? Just explain better what this stuff is, because it is a little bit of a mystery. Like if I want to reconfiguration values, how do I do that? If I want to read additional text, if I want to generate code that is going to be available by the end user first, how do I do that? On and on and on. I think things to watch out for, things that you shouldn't be doing in your source generators. That stuff would be golden. And then how do I build a project that if I want to if I want to have a NuGet package reference in there that the generator is going to use, or that the generated code is going to use, or both? Should that even be a thing that I care about? And if so, how would I handle that? How do I test these things? That all this stuff is like it's just not there. And I don't even feel like what I'm doing is that clean of an implementation either. I don't know if I'm doing the right thing. So, and saying, look at an example, that's the documentation. That's BS. That's not a good answer. It's better than nothing, but it's not a good answer. So that's my ranting. So that's going to be on my list for the next couple of days to look at. And then on Sunday, when I do my stream again, I'll have a little bit more information. The thing that I want to do though, and I think I'm going to leave the stream here for tonight, but the thing that I want to talk about for the next stream is what's called static abstract members and interfaces, specifically in rocks. I want to just do a test to say, target the preview version of, get it to change so that it's targeting, so I can enable that preview feature, static abstract members. Okay. Because I want to create an interface that has a static abstract member. What happens when I do that? Because now I probably have to change. Well, I've got to probably change the compiler references that I have in rocks. Ooh, no. I almost inadvertently closed the stream. That makes sure I'm over here. So, um, what am I gonna say? The rocks here is referencing all these like code analysis C sharp. I have the feeling I'm going to have to use like the preview version of this one. Is there actually a preview version of this? I'm assuming there would be. You know, like to manage, you get packages, and I say updates. There aren't any, but if I say pre-release, yeah, there's a 4.2 final. I'm wondering if that would have, because then I have to be able to say, if you put in a static abstract member, what does the syntax tree look like? If anything, it's probably just a method, but it's going to say it's static and it's abstract. And then I need to include that as a generated method, but I need to make sure that I'm saying it's a static implementation, you know, and make sure that I've done that correctly. And how else does that permeate rock? So I want to do that as kind of a fun experiment, just to do that, you know, no preparation other than that's the target, and see what is that going to change? How's that going to permeate into rocks and have that as kind of, you know, but as I mentioned too, there's also going to be potentially other things that are coming in with C# 11. If they add, if they do the bang bang thing for parameter null checking, which I think is going to be a thing, does that affect if that, you know, can you put that in an abstract method? And if so, in a property, you know, or is that just for something that's not not abstract? But it could be a virtual method, which I can override if it's in a class. And then what does that do? So that may, you know, have some effects. So it's not just static abstract members. It's also the parameter bang bang. It's also generic attributes, because you could have on a parameter generic attribute, and I have to put those on there as well as with methods. One is if you're using a generic attribute there, I have to have that come along with the ride and make sure that I'm handling that correctly. So the main one is static abstract members, but I want to see what else would be coming in C# 11 and have a branch to at least start to be prepared for what changes may be coming there. But I want to do that on Sunday and have a little bit of time to prep to make sure that I can at least target these things, and it may be a complete bust. I don't know, but we'll find out. It'll be an early Sunday morning. I'll have some coffee and we'll be having some fun. So that should be all that I'm going to be doing for tonight. I want to thank everybody again. If you've been watching live or if you watch the stream later, like, subscribe, follow, all that other good stuff. I will be streaming this Sunday at, I think I said 7:30 a.m. Central Time. There will not be a stream next week, Thursday, because I will be down in Knoxville, Tennessee for Code Stock, so I won't be streaming then. So there'll be a stream this Sunday and then one the following Sunday. So that's all I've got for tonight. Again, thank you all for watching and take care.